As we discussed in the sample preparation course, each component of the protein sample loading buffer is critical for the success of the gel run. Glycerol is added to your samples at a final concentration of 5 to 10% so that your proteins sink to the bottom of the well. Samples should also be loaded onto the gel immediately prior to starting the gel run. Allowing your sample to sit in the well for too long can result in protein diffusion, which ultimately leads to blurry bands. You may have noticed that some researchers run their gels at a constant current, while others run their gels at constant voltage. To better understand which approach might be appropriate for your gel, it is important to understand what current and voltage represent. Current is typically expressed in amps, and voltage is commonly expressed in volts. The current, or the rate of electrical flow, ultimately determines how fast your proteins will migrate through the gel. Therefore, if I run my gel at a constant current, I'm ensuring that the proteins are migrating through the gel at a constant speed throughout the entire run. However, as the proteins separate and chloride ions leave the gel, the resistance slowly increases throughout the gel run. As we maintain a constant current, the temperature will also increase as there's a compensatory increase in voltage. If the temperature gets too hot, the gel can melt or our proteins can degrade, which are definitely things we want to avoid. This is why some researchers choose to keep voltage constant. By running at a constant voltage, we will ensure that the temperature does not increase, yet our proteins will slow down toward the end of the gel run. So what is the best solution? In most cases, it is better to maintain constant voltage to ensure that the gel and the tank don't overheat. Another tip is to start the gel run at a low voltage, about 60 volts, for about 30 minutes to allow for better stacking of the proteins and ultimately better protein separation. And then increase the voltage to about 120 to 150 volts for the remainder of the gel run. All of that being said, remember that each gel system has its own different requirements, and you should always check the specifications and recommendations of your gel to determine the best running conditions for your particular assay. After loading your samples and your molecular weight markers, you are ready to begin your gel run. Most gels are run at a constant voltage, about 120 to 150 volts for 90 minutes for most mini gels. When the tracking dye runs out of the gel, your gel run is complete. When performing near-infrared Western blots, blue dye should not be used as this can lead to increased background and low sensitivity. Alternative tracking dyes such as Orange G are recommended. If you must use a blue tracking dye, ensure that the tracking dye runs completely off the gel before moving on with your Western blot. During this section, I hope to provide you with some information about how the gel run works and how we can adjust different components depending on our targets. Now my colleague Carol will discuss some best practices when performing your own gel run.